This topic will look at solving problems involving conic sections, for example, intersections of curves and lines. Pause the slide now and attempt each of these three questions before continuing. First, we're going to find the coordinates where this ellipse intersects this parabola. We're going to use substitution for this, simultaneous equations. There are several ways this could be done, but the easiest way is probably to use the fact that we have y squared here and we also have y squared here. So we're going to substitute 6x in for y squared in the ellipse equation. This leads us to a quadratic in x, which we can solve to find two potential values for x, 6 and negative 15. We now need to consider whether these are both valid. The first thing we can notice is that x equals negative 15 would not be valid in the parabola equation. This is because we would end up with y squared equals and then a negative number, which doesn't have any real solutions. The other way we could tell is by sketching the parabola, the ellipse, and we would see that the ellipse doesn't have any values at x equals negative 15. The ellipse only has x values between just below 10 and just above 10, just above minus 10. So therefore, we're only going to use x equals 6. However, there are two solutions to this, because when we find the square root, there will be a positive and a negative. So the two values are x equals 6, y equals 6, and also x equals 6, y equals negative 6. Sketching the ellipse and the parabola on the same axes, we can see that this is indeed the case. So for question 2, we're going to find the tangent to this hyperbola. We are told that the tangent is in the form y equals mx minus 2 and are asked to find the values of m. So initially you may see the word tangent and think that differentiation will be the way to go here. The reason this isn't appropriate in this case is that differentiating this equation will be quite difficult, as it's not a function y expressed in terms of x. So what we're going to do instead is we're going to use a method similar to what we have seen with circles, where a tangent is a line that intersects the curve once. So we're going to intersect y equals mx minus 2 with this curve and show that it has one solution. We're going to substitute mx minus 2 in for y. We're then going to expand this and write it in the form ax squared plus bx plus c equals 0. So factorising this gives us this line here. We're then going to use the fact that a tangent only intersects once, so therefore there will only be one solution to this equation, therefore the discriminant will equal 0. If this is an exam question, you'd write a statement explaining this. So if b squared minus 4ac equals 0, we know that a is 2 minus m squared, b is 4m, c is negative 8. So this leads us to this equation here. Solving this leads us to m squared equals 4. So m is either 2 or negative 2. We can now just check this on a graph. This is the hyperbola, and we have the lines y equals 2x minus 2 and y equals minus 2x minus 2, and you can see that they are indeed tangents to the curve. For question 3, we are going to find the possible values of c such that this line crosses the ellipse in two distinct places. Again, we're going to attempt to solve this simultaneously. One way of doing this is to substitute x equals 3y plus c in for x. There are other ways of doing this and they will arrive at the same solution. So x equals 3y plus c substituted in gives us a quadratic in terms of y. Because we know that the discriminant has to be greater than 0 in order for there to be two distinct solutions, we can substitute in A, B and C. So A is 18, B is 6C, and C is C squared minus 36. This gives us a quadratic inequality. Remember that when solving quadratic inequalities, it's always best to sketch the curve just to make sure we've got the signs the right way around. So we can see that this has solutions. C has to be between minus 6 root 2 and 6 root 2. We can see from the graph that that is indeed the case. If we have values of C between those two values, the line will intersect the ellipse. However, if C is larger than 6 root 2 or smaller than negative 6 root 2, the line will not intersect the ellipse. Now complete exercise 3b on page 69.